Thanks again for joining us. We are going to be putting all of the practices that we've talked about in the past couple of weeks. We'll card to that playlist right here so you guys can take a look at it if you've missed them. But this is an Ender 3 Max that has seen some things. Over the past few weeks, we've been talking all about maintenance and, well, now we're going to put it into actual practice. What you're seeing is G-code. This is raw G-code made by Cura 4.11 from a client. Except their printer, an Ender 3 Max, is not printing well. It has not been maintained. So, let's go take a look at it. But before we go get onto the standing set, we gotta go through a couple of things here first. Let's start with one. They're trying to do a Pac-Man Voronoi model. And let me tell you, things haven't been all that great. They've had, less than fun experiences. And they thought this was all axis skipping, but when you look at it, it's all extruder based. They have issues with extrusion that is causing the model to not work well. And there are potentially a couple of reasons. This is not a stock Ender 3 Max, but for us to really work on it correctly, we gotta go ahead and run a Benchy. Now, I've already done that. I've ran a bone stock Benchy, and now I've ran one that isn't going to take 2.5 hours. So at least, we got that. But yeah, let's go ahead out to the standing set. Let's take a look at this printer.
And here we are. We've got the Ender 3 Max right next to the Ender 3 V2. Immediate differences? I don't know. And, well, there's good reason for it. This printer is not stock. This one is. For now, make sure you get subscribed if you want to see us be upgrading this, because there's a little bit of wham bam coming for it in the form of a mutant. Or two. Yeah, we're gonna have a lot of fun with this printer. But this one, and I wanted to bring these next to each other because I think it really kind of helps you understand the issues when I can put them next to each other. So let me move this Z-axis up just a smidge. I want to show you guys a couple of things that are wrong with this machine. One, I hate spool holders up top. It's also blocking the freaking extruder. So I'm going to move that spool holder just so that I can get out of the way for the purposes of filming. But this is where the client does want it. Now, again, like we've said before, not maintaining 3D printers is, well, not uncommon. I mean, quite frankly, I don't maintain ours anywhere near as often as I should. Bit of a problem there, but you know what? We deal with the problems that come down to it. And unfortunately, what will happen is over time, the little issues, they start to get a whole lot worse. Let's get this out of the way so we can see this extruder, because this extruder, well, she ain't stock either. This is some sort of Mark 8 / BMG dual gear drive. It's cheap. It's so cheap, in fact, and I will bring out the close-up camera, but the filament has actually ground into the metal over time based on where the spool is located. It's why I believe Enders really need to have external spools holders, or they need to have some PTFE that guides the filament into place. It does appear to have a Capricorn Bowden tube. By the way, we're going to be doing a video all about that to see, does cap tube really matter? And if so, how much? It's got the metal wheels for the bed. The bed is actually quite level. This is a Benchy printed with bone stock settings on this printer the way it is. And we can see a couple of issues in it. I got to get the close-up camera to do that. But I want to show you guys some things. We talked about wiggle, right? This has got a little bit of wiggle in the Z-axis. Look at this. Oh, well, got to hold it first, but look at all that wiggle. And even further, look at all this wiggle. Like, it is, well, I don't know if it's axial. I don't know the right word for this, but it's wiggly as sin, and none of that is good. all of that translates into problems. So we got to go ahead and tighten the eccentric nuts on here. The side with the Z-axis motor is actually totally fine. It's the side that doesn't have the motor. I can free spin one of the wheels, and that means everything is not properly aligned. But let me get the close-up camera, and let's show you guys what's going on with this printer. First off, we can clearly see that the extruder is not stock. On a stock Ender 3, there would be a brass drive gear and then a wheel that would basically hold the filament in place. On this printer, it's got 2 drive gears that are connected via a gear. But I wanted to show off this Benchy, and we can see some ringing on the Z-axis. We can see some extrusion issues on the Z-axis, which is likely due to some sort of retraction issue, which I think is what's causing all the problems for the client. We can see some ringing back and forth. The first layer didn't matter. It wasn't right. That was my fault. And of course, because it's an Ender, we've got some cooling problems. The smokestack looks okay. The layers themselves look okay as well, but we definitely have some issues with the Z-axis. I think a lot of this is going to be due to the fact that none of these V-wheels are tight. But as we can see from this big box of fail here, we've got some extruder issues as well. So I want to take this box and I want to put it where else I own all my things, in a box to my left.
Everything you own in the box to the left.
All right, now you guys can also see the extruder. The extruder here is, well, it's all metal, which is nice. That is actually a nice touch. But we can see she's a little bit wiggly. So let's go ahead. We want to use our Allen key to make sure that this extruder here is tight, and it is not. So let's look at giving it a little bit more pressure. Now, like we've said before, this particular screw on these Mark 8 extruders is going to be more problem than other screws because it's under a fair bit of force at an angle. So now that we did that, we have a lot less movement there. Let's make sure that, tighten that up ever so slightly. Yeah, that worked out quite well. Got to get our handy 10 mil because the 10 mil is what rules the world. We're going to come over here. We're going to grab our Z-axis and we are going to find out where everything gets tight. So, all right, we've definitely just tightened it up there. Beautiful. Same thing with the X here. And remember, again, this is okay. This kind of stuff happens as long as you learn from it. Well, you see, and I don't know if my mic is going to pick it up. Let's see if I can get the mic to pick it up. It is a little bit too tight. Or maybe it's not. Is it rubbing on a belt, maybe? Oh, hey. Well, there's your problem. The belt is actually grinding on the end of the profile. And I've said this before about these printers where the belts run inside the profiles. They're a little problematic. Now, there's a big difference between the Max and the V2. The V2 uses just a little wheel here to basically tension it, whereas the Max, you actually have to undo a couple of bolts, pull it tight, and then screw it back in. The V2 is a much better system. I shouldn't have to tell you that. The other thing I'm kind of missing, and it's something that I griped about, but I'm missing it on this printer, is the wheel on the extruder, which basically means I am forced to do it the hard way. Real quick, showing you guys the damage that was done here. As you can see, that hole is wallered way out by filament effectively grinding its way through. That will happen over time on these cheap extruders. Actually, it will happen on basically any extruder over time. But yeah, something to keep in mind with these machines, that if you do upgrade the metal extruder, make sure that you have some strain relief on your filament because it does need to come in dead straight. The next thing we're going to check for is the bed itself. So we want to make sure that on the bed, and this thing is a little chunky, that the eccentric nuts themselves are tight, because I can wiggle the bed back and forth, so I know they're not. Okay. Now we've gotten that out of the way, the left-right wiggle is now only from the springs having a little bit of movement. The carriage itself is 1. Wow. Much quieter. Wow, that really, geez, that worked better than I expected it to. I need to build a lazy Susan out here. So when we're working on printers, I don't like have to bear their weight for a few seconds. Then I can just simply move them. So I don't know, if you guys want to see a build of that, let me know. Might just make it a Patreon only thing. We are going to look at retensioning the X-axis here. I am a little worried that the X-axis is grinding away. And, well, I've got rubber shavings on my hands, so that's not unreasonable. Now that everything appears to be tightened, you know what, let's just make sure that all the other screws are tight, because if some of them aren't, chances are others might not be. No, that's fine. We especially want to check the ones for the Z-axis itself. I can get like a quarter turn out of them, but a quarter turn is not that big of a deal in the grand scheme of things. Like, if I could do a full turn, that would be a problem. So at least it was assembled well. Oh, that's the wrong way. That was looser. Yeah, see, this side's a little loose. Oh yeah, real loose actually. Let's make sure these top ones are done then. Okay. The client also provided us some filament. This is from GST 3D. I don't know much about them, other than that they claim to be made in America, and their corporate headquarters is in Miami, which is awesome, because I have family in Miami. I'm going to put this over here, because actually that is a better path. I have family in Miami, so I actually reached out to them because when my back is fixed, hopefully soon, I'm going to go take a visit down to see them, because Amber's never met that side of my family, and I'd love to change that. I want to go visit GST 3D while we're down there, because this is like really cheap filament, like $8 a kilo delivered cheap, and their injection molds are pretty cheap, but I'm curious to see. This stuff seems like it prints well, but I can't really knock it out, if you will. What I'm going to do, we're going to start a brand new print in this. We've kind of cleaned up all the kind of issues on this printer. I guess I should also check the extruder doesn't wiggle. Nope, the extruder does not seem to wiggle. Looks like the cap tube connector is tight. Is it a 10 mil? It is a 10 mil. Of course it's a 10 mil. Yeah, it looks like our fittings are tight. Those are all that we want to see. So we're going to go in, we're going to start a print on this. We're going to run another Benchy. We're going to compare it to this one. How'd you like that little time lapse? I love these Osmo Pockets. I'll have links to those in the description. These are awesome cameras for the money, especially if you buy them secondhand. I was just taking a look at things in between takes because, well, we got another Benchy and we've solved some of the extruder problems. This is the second Benchy here. That's our first Benchy. But we definitely have some issues where now we're not skipping, but we're still over-extruding. So I said, let me see about the tension on the screws. This is a dual gear drive system. This is an upgraded extruder. This is not a stock extruder from Creality. This is not how they come. So it uses a toothed gear with small little teeth in it that enable the filament to be grabbed. Well, it's also done on a threaded screw. So this side of the screw looks great, but that side of the screw, no bueno. I don't know if the camera's focusing and I can't tell 100%, but let's use a pointing implement. The threads are completely gone here. That's exactly where the ball bearings land for this piece. So what does that tell us? Way too much pressure. Like way too much freaking pressure. We're gonna remove this because this spring is way too tight. I don't have a smaller spring to put in here, but this also lets us assemble everything without a spring in place, which will probably make life a little bit easier for me. We're gonna pull the filament out of the printer. While we're doing that, we can get this screw out. All right, filament's out. That will make it a lot easier to go ahead and get everything out. Oh boy. Wow, this thing has got a ton of wear. It's literally, jeez, that's just not safe. Yeah, this whole thing is messed up. I am going to oil this because it definitely needs it. So I'm just gonna put some oil in here, because those bearings were very dry. Get this screwed back down. All right, now we have this spring, and this appears to be some sort of a riv nut. Yep, it's a riv nut. We need to get the spring compressed and back in place. There we go. Nice and tight, just like my segue to our sponsor, 3D Musketeers. 3D Musketeers is here to help you, one, fix your broken printers, 2, utilize awesome printers like an Ender 3, but more likely a Prusa Mark 3S or Prusa Mini to get those ideas out of your head and into your hands with full art-to-part rapid prototyping. Let me explain that for you. You bring me a napkin sketch, and then we give you 3D printed part. Straight up, art to part. We do everything from CAD, CNC milling, laser cutting, 3D printing, of course. And when we're doing our CAD, we also are able to do design for manufacturing and design for additive manufacturing. So lots of opportunities out there if you want to make awesome. Speaking of making awesome, we are also hiring. We desperately need help on the CAD side of our business. So if you think you got the skills to work with us here at 3D Musketeers, shoot us a line, youtube@3dmusketeers.com. We utilize Fusion 360, so that will be a requirement to work with us. But hey, it's a pretty easy program to learn. You've probably watched me struggle through some live streams for it. And if you haven't, I'm going to reluctantly card to those videos because, oh man, some of them are a little embarrassing as I ride the struggle bus to try to do things. Because remember, I have 2 business degrees. I'm not the engineer on the company. But either way, guys, we are here to help you out. We would love to have you join the team. So if you think you got what it takes, shoot us an email. And hey, if you want to kick us a couple of bucks, do so over at Patreon. Make sure you get subscribed and leave a like as well. Let's get back to the video. The next thing we're going to do is we're going to check spring pressure. What we want to do, go ahead and feed the filament through, and we want to pull. I need to lock the motor, so we're going to go to prepare, move axis, move extruder, move it 1 millimeter. There we go. We moved it. So now when we pull back on the filament, we don't want it to come out. Now the problem is we don't have a lot of movement with this spring. This spring is super stiff, and I don't think I have a way to replace it. But this spring is likely way too stiff. I've got this screw back so far out, it doesn't even matter anymore. That's literally as light as I can make the pressure, so we're gonna leave it just like that. This is probably too much pressure, but that's what happens sometimes. There's nothing we can really do to affect that. But this should really help it when it comes to getting the extrusions taken care of. I do believe that we are also not extruding the right amount of material. So I'm gonna get a tape measure and a Sharpie because we are gonna set our steps per millimeter because I believe this is a lot closer to 100 and I think it's at like 144. And that can easily account for a lot of the issues that we are still seeing in this Benchy. I know that I cut the extrusion down on this Benchy because I heard it skipping a bunch. We still have some issues with the extrusion starting to jam, but I'm reasonably confident that a lot of that is all here inside of the extruder. Now, I've got stock-ish extruders. These are actually some of the better extruders. We'll link to both of them down in the description so you guys can take a look at it. Affiliate links, of course, but this appears to be real cap tube. I'm honestly not certain because I don't have my real cap tube to test, but I'm worried that we have too much spring pressure, which is going to cause a lot of issues. So let me go ahead, let's do our steps per millimeter, Let's see if that's our problem. So I love this little general stainless steel ruler that I have. It came with my Lulzbot Taz 6. If I can find some like this, I'll link to them. But it's nice because it's thin, it's a straight piece of metal, and it will easily allow me to mark off 100 millimeters, which is right there. And yes, I'm not being very scientific about this. I'm actually not trying to be. I want to get it reasonably close. So let's go 100. That is 100 millimeters, and we're going to see if it extrudes 100 millimeters worth of filament. If it doesn't, we're going to go in, we're going to adjust the steps per millimeter. We're going to go from there. Now, if this goes correctly, this black line should be right at the edge of going into the extruder. If it goes inside of it, we've got a problem, and it is inside. Ooh, but just barely. All right. Well, hey, that means we're just barely over-extruding, which made sense. It looked like we were. All right. I dropped it a little bit. Every time you update your printer's firmware, you will hear a beep, and that is to confirm everything is all right. And then the last factor becomes the plastic. Once we get the extruder running well, the hot end is running just fine. The cooling is pretty bad on this. It will eventually need an upgraded cooler. But the cooler is not affecting the extrusion issues that we're seeing. If it was heat creep, it would be jamming, which I don't think it's jamming from heat creep because it's able to push through it. I think a lot of this is dealing with this extruder being a little upset. Oh, that's perfect. Oh, it is like right on the edge. Look at that. It's right there. That's exactly where I wanted it. 140 steps per millimeter is the right answer for this. I'm glad we got the steps per millimeter taken care of. All right, I'm gonna run another test and we're gonna see where we're at with this machine. I'll be back with you. Benchy's done. And a lot of the problems that we saw on the previous print are gone. We definitely had some retraction issues and we still have a couple. We're seeing some stringing. But on the boat on my left, your right, the front bow has got quite a few places where it did not extrude. This is likely due to back pressure causing the extruder to skip, and then it just not working. Print number 3, all we did was tune the steps per millimeter on this machine, and now it's running considerably smoother. There is one problem, and I can't figure it out. I'm gonna need your guys' help for this one. When the thing goes to start a print, before it lays down the purge line, before it starts doing any of that, it homes and then it raises 4 millimeters. Why? Ain't got a darn clue. I am baby stepping negative 4.1, 4.2 millimeters to get a good constant first layer. Mind you, this bed's still a little bit out of whack, but that's okay. We're getting some better results. Now, I have never used this filament, so it is still a bit of a wild card for me. It is stringing at 207, so turn it down a little bit, we'll be okay. We do have some other small issues in the print. Let me get the close-up camera so you guys can see this, well, up close. On print number 2, we can see right here at the front of the bow of the boat that we had some under extrusion that resulted in, well, an empty layer. We can also see that it gets a little rough all around the boat, especially on these vertical surfaces. After tuning, we see that that empty layer completely gone. We're seeing a lot more smooth walls going up, although we do have some artifacting right there. We have a couple of lines. There's a very obvious line right there. You can see the screwdriver gets stuck on it, and then one a little further up. I think these are completely related to cooling, as we can see the front of the boat is not properly cooled. This can happen. I don't really have a good solution for this without reprinting an entire fan duct, but this is common on a stock Ender 3 Pro. By the way, this is a Pro, not a Max. I was told it was a Max. Definitely a Pro. Even says on the sticker it's a Pro. Took me a little bit to figure out why it wasn't printing in the middle of the bed, because a Max has a bigger bed than a Pro, and this is a Pro. But otherwise, the print looks really, really clean. We definitely have some issues with extruding. I don't know what's causing this. It could be axes still being a little bit wonky. I'm not 100% sure. I'm gonna play around with the cooling first, but that's gonna have to happen a little bit later because, well, we're 3 Benchies deep. We've solved the major problems that we had on this boat, which were a lot of these retraction points not working well, empty layers constantly. We've solved that. We've got the printer in tune a little bit more, but we are still, of course, dealing with some issues. Now, the client specified some prints that they wanted to see printed, so I'm gonna go get those sliced and get those rolling here. But otherwise, this printer's gone through some of the basic upgrades that we talked about in our previous video about not only maintenance on an Ender 3, but also potential upgrades. We'll card to the Ender 3 playlist right above me. They've got the nice extruder, although I still wish this had a lighter spring. They've got a Capricorn, I think, bowed into them. I'm not certain this is a real cap tube. It's difficult to tell without taking it apart. And, well, I don't want to do that. It's got a regular piece of glass. Now, I don't know if this is something that came with the printer or if they added that on separately. And I think there is something underneath this glass. I think the clips are superfluous. I'm pretty sure he bonded the glass to the printer. It also has the metal wheels for handling the bed leveling, and this printer actually came pretty well leveled, so I can't complain about that. And they've added a few aesthetic things, like there's a little box up front where you can hold some things and a knob to control the Z-axis up and down manually. We are on the home stretch of this printer, and I'm glad. Had a little bit more time than I thought we would need on this, but that's kind of the deal sometimes with printer maintenance. You walk into it, this is somebody else's printer. I've never had hands on this until today, and that's what we're dealing with. It is what it is. We've got some improving Benchies, which is good. That's what we like to see. But I will have to update you guys in a future video, so make sure you get subscribed to see what we ended up doing, hopefully to solve this 4mm issue, because as it stands, I'm just gonna hard code it into the G code to push it down 4mm before it starts to do the purge line. Pretty simple to do there. Anyways, guys, that's all I got for you today. Make sure you leave a comment down below. What do you think of these upgrades? This specifically. This was not the BMG style extruder that I was expecting, but this extruder is actually not bad. I think the spring pressure is a little bit high, but I think that can be easily solved here, right? All you gotta do is replace it with a lighter spring or compress the spring and heat the crap out of it so it loses some of its spring pressure. But we went through, we made sure we lubricated the printer, we adjusted all the V-wheels so it's got way less slop in it. But given that this is not one of the newer Enders, like an Ender 3 V2, it is going to suffer from some weird oddities like belt tensioning being a little bit arbitrary and you just kind of have to go for it rather than being able to quickly turn a knob to adjust it. But I think we're on the right path to success. I'd love to know your opinions down in those comments. How did I do? I am obviously missing this 4mm problem. It is not in my start G code. I looked. It leads me to believe that the printer's firmware is a little bit hokey, and I'm not a huge fan of reflashing firmware on printers that don't belong to me, because, yeah, if you brick it, you're out like $100 for a new mainboard. And let's be real, if I'm putting a new mainboard in a printer, it's not going to be the stock mainboard, all right? It's going to be like an SKR Mini. We're going to go the full enchilada on it rather than, you know, just replacing it with stock components, because at that point, now it's just fun. Either way, stay safe out there. Don't forget to call your loved ones, and as always, keep making awesome. Make awesome like this. Maintenance is not difficult. This kind of stuff, not difficult. Yes, small things can get you stumped, but that's okay. I have faith in you. And if you need help, email us. Links are in the description. Have a good one. In a box to my left. Thank God that was actually to my left. Hey, thanks so much for watching this video, and a special thank you to our patrons. Without you guys, none of this would be possible. And if you want to support the channel directly, you can head over to patreon.com/3D Musketeers. Links will be in that description. where you can support us for as little as $1 per month. Every dollar goes right into making awesome videos just like this. Right below me will be the Ender 3 playlist where this video will be housed so that you can learn all about the Ender 3 and the cool things that you can do with it. And make sure you guys get subscribed because that mutant is coming soon, and boy, I wonder what printer it's going to go on. It may not go on this specific Ender 3, but it's going to go on an Ender 3 style printer. And I'm excited for that. You should be too. Right next to it is going to be the series all about printer maintenance, because we're going to keep doing that series. We got a lot more maintenance topics to cover for you, but this printer came in the shop, so we had to get it done. I'll see you guys down in those comments. Take care.